Now, the only question I had a request for was 12, but I am going to have a look at 10. So what we're asked to do here for 10 is we have a line parallel to this line that goes through minus 1, 2. Now, what most of you did correctly was get the slope. So there's two ways of getting the slope. You can rearrange for y equals mx plus c, or you can say that it's minus a over b, which is minus 2 over minus 1, which is 2, okay? And then sub it into the slope formula. Now, what I think might be a slightly quicker way is to say that any line parallel to this line is also going to be 2x minus y. But it's going to be plus some different constant. So the only difference is going to be the constant. Okay, now how do I find the constant? Well, I know the point minus 1, 2 is on this line, so I'm simply going to sub in minus 1 and 2. So minus 2 plus d equals 0. So d is 4. So 2x minus y plus 4 equals 0. Okay, just another way of doing things. Okay, now I did have a request for 12. So for question 12, A and B are 2 points and find the equation of their perpendicular bisector. Okay, so if you imagine having A here and B up here, a perpendicular bisector is going to split them exactly in two at a right angle. So what I want to do first is find the midpoint, okay, and I need the slope of AD because the perpendicular bisector will be perpendicular to that, okay. So slope of AB, okay, x1, y1, x2, y2, y2 minus y1 over x2 minus x1 is going to become minus 4 over 5 minus 1, which is minus 8 over 6, which is minus 4 over 3. So that's the slope of AB. So the perpendicular to that is 3 over 4. Okay, so that's the slope of the perpendicular bisector. Then the midpoint. Okay, so use a big capital M here for midpoint. Is x1 plus x2 minus 1 plus 5 over 2 and y1 plus y2 over 2, which gets me to 0. So now use the equation of a line. So y minus, and I can use, I need to use this point and this midpoint. So 0 is the y is minus 4 over 3. Sorry, 3 over 4 was the perpendicular slope. 3 over 4 x minus 2. So multiply across by 4 and multiply the 3 in. So 3x minus 4y minus 6 equals to 0. Okay, now, so moving on today, what we're going to look at is finding the area of a triangle. Okay, now your table book shows you this formula. Okay, but it says one vertice must be the origin. Okay, it's there, page 18. Okay, area of a triangle. Now, but the thing is, they only give you x1, x2, y1, y2, but there's 3 vertices of a triangle. So we just need to make sure that one of those vertices is the origin. Now in this case, this one is, okay, 0, 0. So I'm going to label this one x1, y1. I'm going to label this one x2, y2. Again, it doesn't matter. The fact that it's modulus here means we only take a positive answer. So if I get these, if I was to do this as 0.2 and this is 0.1, I would just get the opposite sign inside here, but that's not going to matter because I'm getting the modulus, the absolute value. So area is a half times x1, 7, times y2, 0, minus x2 15 times y1 3, which is a half times minus 45. Now, because it's a modulus, I just take the positive value. So it's a half of 45, which is 22.5 square units. Okay, square units. Now, what happens though if one of the vertices is not the origin? Okay, so here's an example of that. Now, let me just grab a different color pen. What we need to do is just simply what we're going to do is we're going to move the triangle so that one of the vertices is at the origin. Because if we imagine a triangle drawn there, or a triangle, the same shaped triangle drawn in a different place, you're not going to affect the area. You're just moving it, and I'll show you on a graph when we finish. So, you can pick any of the points to move to the origin. Any of them at all. Okay? Normally just pick the closest one. So, these two, it doesn't really matter. So, I'm going to add 3 to the x and take away 4 from the y. Okay? To move this point to 0, 0. Now, if I just move this point, I'm going to change the shape of the triangle. So I need to move the other points the exact same way. So this becomes 7 minus 2. Add 3. Take away 4. So this becomes 9, 6. Okay? So now I have a vertice as the origin. So I can label this one x1, y1. Label this one x2, y2. And away I go. Okay, so a half times. Now, so it is x1 times y2. So 7 times 6 minus x2 by y1. So take away 9 by minus 2. Okay, so a half of 7 sixes, which is 42, plus 18. So I get a half times 60. So I get 30 units squared. Don't ask me why I'm doing the squared before the s. Okay, so if we look at that graphically, I'll just move the camera, apologies. If we look at that graphically, there's that triangle. Okay, there's the triangle. So I'm going to move minus 3, 4. Let me just zoom in slightly. Okay. Okay, too much. I'm going to move minus 3, 4. You can see the area there is 30. Down to the origin. Now I've moved the area, so I have to move the other ones. So I have to move my 4, 2 to 7 minus 2. 7 minus 2. Okay, it's not snapping exactly for me. And then I have to move my 6, 10 to 9, 6. 9, 6. Okay, now it's not snapping to whole numbers, but you get the idea. Okay, so the area, so these are slightly off, so that's why it's not exactly 30, because it's not snapping to whole numbers for me. But the area remains the same. All I've done is simply move the triangle down.